Hello, my name is Dr. Muhammad Ayoub. Today I am going to present novel yttrium promoted nickel alumina based oxygen carrier using novel ultrasound irradiation method for the chemical looping combustion. The details of this technology are given in this slide. Research background and problem statement. As the world's population keeps growing, due to which the energy demand has been increased, to meet this energy requirement, the usage of fossil fuels in the energy production plants also raised. That results in an increase of CO2 emissions in the atmosphere, which is called greenhouse gas effect, responsible for the increase in Earth's temperature. Therefore, it is necessary to either control CO2 emissions or capture from the atmosphere. Chemical looping combustion is one of the technologies of carbon capture and storage approach. It consists of two interconnected fluidized bed reactors known as air reactor and fuel reactor. Air flows in the air reactor and fuel in the fuel reactor without any fuel and air interaction. A metal oxide, also called oxygen carrier, circulates between these two reactors. The circulation of the oxygen carrier depends on the flow rate of air in the air reactor. The oxygen carrier transports oxygen from the air reactor to the fuel reactor by absorbing oxygen from air and provides to the fuel. Similarly, it repeats multiple redox cycles. The end stream of the fuel reactor consists of CO2 emissions and water vapors. After condensing the water vapors in condenser, inherent CO2 can be captured. Oxygen carrier is the keystone of the chemical looping combustion process. Mostly oxygen carriers synthesized from transition metals. The problems associated with oxygen carriers are agglomeration, oxygen transfer capacity, spinel compound formation. To resolve these issues, we have prepared a novel nickel-based yttrium promoted oxygen carrier. This oxygen carrier was prepared using sonochemical method, which was compared with the conventional method. Perspectives of current work. First, novelty. Two new aspects are proposed: ultrasound irradiation method and promoter yttrium. Second, usefulness and application. The ultrasound process has many benefits over other processes. It can enhance the surface area of the oxygen carrier by lowering particle size and increasing metal to support interaction. For the second proposed solution, yttrium promoted on gamma alumina is studied to enhance the catalytic performance. However, the use of yttrium as a promoter to nickel for chemical looping combustion has not been widely reported in the literature. Third, market and commercial potential. As more companies and research institutions work on CLC technology, the market could become more competitive, potentially driving innovation and cost reduction. Fourth, environmental friendliness. One of the primary advantages of CLC is its potential to capture CO2 during combustion without the need for separate capture systems. The ability of nickel-based oxygen carriers to regenerate can be utilized for a number of different redox cycles. Fifth, commercialization potential. Nickel-based yttrium-promoted oxygen carrier has significant potential for commercialization in chemical looping combustion, especially in industries and applications where carbon capture and reduced emissions are critical. Advantages and applications. Synthesis of oxygen carriers using new proposed method requires less energy and takes much less time. The results showed that the physiochemical properties of oxygen carrier prepared via sonochemical method were improved. The advantage of using promoter yttrium not only increase value oxygen transfer capacity, but it also reduce the formation of spinel compound nickel aluminate and enhance the stability over 10 redox cycles. This type of oxygen carrier reduces overall cost of the process. The synthesized oxygen carrier can be employed for the variety of applications, including chemical looping, reforming, catalytic pyrolysis, gasification, and steam reforming, among others. How it relates to STDG? Because it is a sustainable process and it produces clean energy. Thank you.